Alright, one more video on graphing a rational function, and we'll start it the same way we start any other one. We look at factoring the top and the bottom. Alright, and now our whole, we see these factors divide, so we have a whole at -2, and we're left with 3 over x plus 1. Okay, so far so good. So now, what's distinguishing this video from the other two is really the end behavior asymptote. So in general, the process in all these starts the same, right? And these answers all sort of come from the same, using the same process. It's the end behavior asymptotes is what I want to draw your attention to. So zeros. So what would make this 0? This is tricky. Some students say things like 3. I think the 0 is 3. But again, if you set this equal to 0, right, and then you multiply both sides by x plus 1, you get the equation 3 equals 0. That's not a true statement. So there are no zeros. There's nothing you can plug into this to make it 0. So there are none. A vertical asymptote? Well, at x equals -1. Holes, looks like there's a hole at -2, comma, and then we plug into this one. So 3 divided by -2 plus 1 is 3 over -1, which equals -3. 2 -3. A y-intercept occurs when you plug in 0 for the function. And when you plug in 0, all this goes away, right? That turns into 0, that turns into 0, that turns into 0. You get 6 over 2, which is 3. So 0, 3. Let's go down to the limits. So as x goes to infinity, right, as x goes to infinity, we can do all our analysis, as usual, on those leading terms. So in the long run, this function behaves basically like 3x over x squared. And one of those x's can cancel, so this really becomes 3 over x. So in the long run, this basically starts to look like 3 over x. Now as x goes to infinity, what happens to this? Well, the denominator gets really big, right? So this goes to 0. And if you go to negative infinity, the denominator gets really big but negative, but still, that's approaching 0. So as x goes to plus or minus infinity, the function goes to 0. So that's going to explain those limits. And again, from there, you can reason that, well, that must mean the end behavior asymptote is just y equals 0. And you'd be right. Okay. So in the other videos I did synthetic division, right? If you look here, I did synthetic division as another way to get the end behavior asymptote. But that was only because you can actually do the division. And what I mean by that is, right, you could divide this into that because the polynomial is bigger. It has a bigger degree than the bottom. Here, the degrees are the same, so you still could get away with doing it, right? I mean, after we simplified, you could still get away with doing it. Here, you can't really do this division. It would be me like asking you to divide 4 into 3. You can do it, right? We can get a decimal here, but as far as writing it as an improper fraction, to a mixed number, this already is as simplified as it can be. It's like this is 0 plus 3 over x plus 1. So we don't really need to do that. But we do need to finish graphing it. So I don't have any zeros. I get a vertical asymptote at x equals -1. -2, -3, I have a hole. 0, 3 is my y-intercept. And behavior asymptote to y equals 0, so we can dash it in, or you can just remember. And now the idea is the function needs to go through that point and approach 0 as x goes to infinity. And it needs to go in the hole and out the other side. Here's our function. Okay, that's kind of that's just a I don't want to say run-of-the-mill, but it's a rational function you're probably most familiar with seeing.